Anyone investing in humanoids is probably really stupid right now.
I just don't think it's going anywhere.
I just don't think it's going anywhere. We're the most deployed construction robot in the world. All of the technologies that robotics has invented doesn't work in construction.
Why is that?
The same reason you'd rather have a dishwasher than a humanoid standing in your kitchen. It's always going to be purpose-built.
You write a bad piece of code, you might lose a little bit of money. You mess up something in construction and there are lives at stake.
By the time they finished, they discovered that that building was actually sitting 1 foot over the property line, paying rent in perpetuity. 1,000 apartments became uninhabitable. We're replacing a process of people snapping chalk lines. That's how you draw straight lines. The Egyptians invented that to build the pyramids 5,000 years ago. And humans are using those marks like Lego instructions. Do you really want a robot on its hands and knees snapping this chalk line? What our customers tell us is that they have yet to see any good use case for humanoids on their job sites. Our philosophy is that we're building a power tool. There's no AI in that.
Okay, now I need to understand how, what, how?
The reason it's wrong, I will tell you.
Hey climbers, welcome back to this episode of Climb by VSE. I'm Jay Kapoor, General Partner of VSE Ventures, and I'll be your host today. I am so thrilled to have on the show Dr. Tessa Lau, who is the co-founder and CEO of Dusty Robotics. And she is one of the true OGs of the construction robotics industry. She's been putting robots on live job sites for the past decade, so she's seen firsthand how both tech and behavior has changed in construction. Dusty's robots print full-scale building layouts directly onto the construction floor, and they've put down over 330 million square feet of layout as of today. There's even data centers that are mandating them on job sites before a single thing goes in the ground. So Tessa and I got together to unpack exactly what got us to this robotics gold rush we find ourselves in today, how frontier models are making her job easier and harder, and how you get general contractors to actually trust robots directly on the job site. We also got into the very hot debate about purpose-built robots versus humanoids and what we think the future holds for both. This is such a fantastic and wide-ranging conversation, and I'm so thrilled to get to join me for it. Tessa, thank you so much for joining me on Climb today.
It's fantastic to be here. Thank you.
We've been trying to do this for a little while, and with the Dirty Jobs Summit coming up, it connected us, and there's so much that we can dig into on construction, robotics. Maybe let's start with laying the landscape a little bit. You have been putting robots in the field longer than really anybody. What specifically has created the gold rush moment today? What's changed in the last 2 years to create this excitement around robotics and physical AI?
So I think there's a lot of things that are coming together at the same time. For the last couple years, we've been seeing innovation in the hardware behind robotics. And then now recently, we're seeing the innovation in the software behind robotics. And everyone's getting really excited about the potential for maybe LLMs or frontier models to build better robot brains. And so I think that that gold rush is stemming from everyone thinking, okay, maybe this is finally the year that robotics is going to have its open AI moment.
Can you pinpoint, was there a specific model? Was LLM? Was it, GPT 3.5? Was there a moment where you went, oh, wow, this is now going to have, it's kind of the Cambrian explosion moment?
So I think there's different answers depending on whether you're a robot founder or whether you're a VC.
Okay.
I think the VCs are piling in because they're looking at it and they're thinking, okay, maybe finally someone's going to crack the nut. Someone is going to say, we're going to build that general purpose humanoid robot or whatever.
Yeah.
That's going to solve all the world's problems and it's going to obsolete labor. And then we all just wonder what we're going to do next, right? But I think the reality is very different from where the dollars are going in VC. Okay. Because I think the reality is that it's never been easier to build a robot, but it's still just as hard to build a robot company.
Okay, so say more about that. What's the distinction in terms of obviously building the product? What's the hard part about building the company?
So everyone assumes building the product is the hard part, right? That's why I spoke at ICRA last year, the big conference for robots and automation. And a conference of 7,000 people, all of whom are super excited about how do I build robots. And all the vendors are selling you robot parts and motors and sensors and actuators and things like that.
Yeah.
But those are not the hard parts of actually creating a robot company. The problem with building a robot company is that you have to come up with a business model that where people are actually going to pay enough money for you to build the robot that you want to build. Mm-hmm. And that's the hard part in robotics.
How do you tackle that? I mean, you've been doing this for a little while now. You're in the construction space. how do you convince GCs and folks in construction to let you build the robot that you need to build?
So I like to say technology is easy, behavior change is hard.
Okay.
The hard part is finding that product market fit and solving the problem that makes people come to you and say, I need your solution. And so what we've done at Dusty is we've identified a problem in construction that everyone needs. The problem that we're solving is there's a small version, there's the big version. I'll start with the small version because it's easy to understand. When you're building a building today, you design your building in software in 3D, like a CAD tool like Revit, and then you go to build it in the field. And what you're building off of is typically paper plans.
Yeah.
And those paper plans get transmitted to the site with people on their hands and knees, using measuring tape and string, snapping chalk lines in order to transfer those plans to the floor so that everyone knows what to build, where. And so we've solved that problem by introducing robots that are 10x better than people doing it with chalk lines today. And that's what's creating a huge amount of interest and adoption in the industry.
So going back to the old process, right? So you got the chalk lines, the string. How often are you seeing the imperfection transferring from BIM to, the big rolled up plans that we all imagine when we think about architects on a job site to then actually laid out? Extrapolate that for me. What happens if somebody gets something off by a couple of inches?
There's a building in San Francisco. It's a multi-family residential tower, like 40 stories tall. And they laid the foundation for that building and they didn't double check it. And then they built the tower. And by the time they finished, they discovered that that building was actually sitting 1 foot over the property line into the neighbor's yard.
Oh, no.
So I don't know how you feel about your neighbors. Maybe you have a good relationship with them, but you can imagine this neighbor was pissed.
Yeah.
And so that building owner is paying rent in perpetuity to that neighbor for occupying a little bit of his space.
I mean, I'm sure the neighbor's not so mad about that.
Well, yeah, I know. But, imagine, your neighbor builds like their garage over into your yard, right? No one likes that. Yes.
Yeah.
Exactly. And so that's a layout mistake. And so that layout is the fundamental thing that underpins all of the construction projects. It's all about putting things in the right place.
Yeah.
And if you get that wrong, then everything downstream gets messed up.
And how often are changes happening? Because I got to imagine, like, you show up and you realize, oh, actually, I thought the foundation was this, but it's maybe a different kind of rock or something, and we need to now move things over. How often does that happen before you're putting a BIM model into the real world?
So the big version of what Dusty does is we're the orchestration system for construction. And what that means is that all of that work that happens in the field where, people are wielding hand tools and on their hands and knees building the building, all of that work has to get coordinated. And the way it gets coordinated today is paper plans and verbal communication, right? And so what Dusty's doing by bringing information onto the slab, it's not just a printer and it's not just telling you where to put things, it's also telling you how to build it. It's telling you in what order to build things. And so it's serving as that orchestration layer that is telling everyone on that site what to do. And that's how we eliminate errors. That's how we eliminate any changes or any conflicts or anything that goes wrong or sideways on a job.
Uh-huh. Why go as a service? I guess that's the thing. You now talked about this idea of it's easy to build the robot, it's hard to build a robot company. And I keep coming back to this idea of part of that is the business model, right?
A lot of it is.
And we've seen robots be sold outright as CapEx. We see folks that are now trying to sell labor, as they say, right? And then there's, kind of as a service models in between. We talk about the different business models you've seen in robotics, and then, what are the pros and cons of the as a service model?
Mm-hmm. I don't know if you know this, but my company before this was Savioke. We were building robots for the hotel industry that would deliver room service to guests. We invented the term RaaS, robot as a service. And so we had to do that because hotel owners didn't want a capital investment in robotics at the time. And so my observation after having built 2 robotics companies at this point is that one of the hard parts in robotics is coming up with the business model. And the interesting thing is that every single industry is different. They all have a different way they want to buy. There's no one size fits all. So you can call it RaaS, but when we first started Dusty, we were actually selling LaaS, layout as a service. That was how we launched the product into the market for the first time. And so when we were doing LaaS, layout as a service, what we were selling was the outcome, was the marks on the ground. And you would pay us to do those. We would operate the robots And in some cases, we'd snap the chalk lines if the robots, couldn't do the job. And so we would deliver that outcome. And that's what our customers were paying for. But we did that in order to educate the market, in order to have time to refine the technology and learn what it needed to do. We took all of the learnings that we did from our time doing layout as a service, baked it into the robots. And so now the robots are much more capable than they were when we started. And so that was a stepping stone to getting to our eventual model.
Yeah. Well, tell me about those first couple of deployments. When you got out there doing layout as a service before there was even a robot out there, what resonated with the GCs? Why were they like, oh, thank you so much. I need someone to do this. And then as you introduced the robot, what did you think was going to resonate and what actually resonated?
So one of our early customers told me, construction companies are risk management enterprises that happen to produce buildings.
So sorry, say that again?
Construction companies are risk management enterprises that happen to produce buildings. Okay. The buildings are the side effect,
yes.
Right? They build buildings as a secondary artifact, and their first priority is managing risk. You know why? Construction is one of the riskiest industries on the planet. Not only is it dangerous and unsafe, which is why robotics is a great fit for it, but the average profit margin for a general contractor is 3%.
No way.
Yes, that's a tiny, tiny overhead. And so one job is the difference between massive profit for them in a year and going out of business. Yeah. And so they're not in the business of taking a lot of risk. They're in the business of taking calculated risk. And so when Dusty comes on board, what we're doing is we're reducing their risk because we're ensuring that everyone's building on exactly what they're supposed to be building. And you're not trusting people to interpret, and you're not trusting human judgment, or you're not trusting skill, because that skilled labor is disappearing. It's getting more and more scarce every year. Yeah. And so if your business, it depends on all of those things coming together in order for you to build the right building at the right time, then you're looking for anything that can help you reduce that risk. What we thought we were building at the beginning of Dusty was solving for speed and accuracy. Mm-hmm. And that is true. That is how we deliver less risk. But when we first started thinking about this, yeah, robots are fast. Yeah, robots are accurate. And so it's easy to tell a story about speed and accuracy as just look at a robot. That's what we're going to give you. We're going to give you a faster, someone doing the job faster than a human is going to do the job, and they're going to be more accurate at the same time. And so that's how we started. But our savvy customers, the sophisticated ones, especially the ones that have been with us for the whole 8-year journey, those are the ones that are seeing this as a risk demitigation tool.
Is that something that has to change in the attitude of the construction industry? And I mean specifically, one would think speed should matter because the more you build in a year, the more projects can come online, the more revenue you can make. And kind of what you just shared here is actually speed may matter a little bit, but it doesn't matter as much as risk and safety and kind of, having the confidence to kind of do that. We have a lot of things to build in this country. Every day we hear about, homes and kind of all the things that we have not built, infrastructure in this country. Is that just is speed just second priority? Is it just always going to be like?
I can explain how they all connect together because this is really, really interesting when we discovered it. So when we first started selling Dusty, we initially started selling it to the trade partners. Yeah. So like a drywall contractor, someone who builds the walls inside of a building, they were the first adopters of something like Dusty. And the reason why was because they saw it as a labor replacement tool. And a GC said, well, I don't do the labor, right? A general contractor is a project manager. Yeah. And so they don't have the people that build the buildings, they manage the people who build the buildings. And so they were like, I don't need this tool, I don't have the labor, or, you're automating a job, but I don't do the work. And so we started selling first to trades. And the drywall contractors were the first to adopt because drywall layout is about 70% of the layout in a building. Mm-hmm. And so our first customers started using this to replace labor. And they discovered that this is so much faster than their crews doing it. And they took some benefit away from that, which is that if you normally have a week to lay out your floor, and with the robot you can do it in a day instead, then you've got 4 extra days that you can use to build the walls. And you can use that time to pay less labor costs. Because instead of having to pay overtime or pay people to work on weekends, you have more days in which to accomplish the same amount of work for the same price. Yeah. So your labor costs go down. And so they were saving money. And so they're like, this is great, right? And I love these robots. But then the GCs found out about it. And they're like, okay, this is working. It's been proven out. Our contractors are using it. And so I want to use it, not to replace labor, because I don't have any labor, but I want to reduce my risk. And we're talking about risk now. So that speed, the benefit that the drywall contractor took, now gets handed to the general contractor. Yeah. And the general contractor says, okay, instead of you having that extra 4 days, I'm going to take those 4 days and give that to my schedule. And so now I have a buffer at the end of my project. So I've got extra time to deal with any issues that came up and still deliver on time. And so that's my risk mitigation strategy. I'm making sure that everyone's working together, they're all coordinated, and I'm getting extra time on my schedule.
I see a lot of robotic, let's call them point solutions, get stuck trying to figure out who in the construction stack to sell to. They'll start by saying, I'm going to sell it to a sub. Maybe it's a tool for electricians to wire harness or whatever. And you actually realize, oh no, they need the GC to pay for it. I've heard this story again and again and again. And then the GCs are going, I am overloaded with people trying to sell me shit. So having sold the GCs successfully, what actually gets them to buy? What is the behavior change, the business model change that just gets them to say, okay, this is a solution we want to put in the field?
So the advice that I would have for anyone trying to follow in our footsteps or stand up a successful construction robotics company is that you have to understand all of the players in the ecosystem and how they all connect and what they each care about, because they all care about different things. So the trade contractors care about the labor, and that's their business. They monetize people doing work for pay. The general contractors, they care about coordination and schedule. They're on the hook if the building doesn't get delivered in time. Yeah. And if it doesn't, then they're on the hook for millions of dollars. And so they're looking for ways to standardize execution, to de-risk, and to get everyone to work well together. Because if I'm fighting with you, then we're not building, right? And so they're trying to get to eliminate that conflict and just get everyone happy, building together and delivering the right thing on time. And then there's the owners, and the owners care about something different because it's their capital that goes into the building, right? Kaiser building a hospital, that's their dollars that they're spending building that new facility. They care very much about when they take delivery and how much it costs them. And so every stakeholder cares about a different thing. And what we did at Dusty is we figured out the angle that our solution has for each of these stakeholders. And so whether or not they are signing the checks or whether or not they're signing the contracts, they still get something out of it. And we have to be able to tell them what they're getting out of it.
Yeah. So on that piece, where are we in the adoption curve with tradespeople and robotics, right? And I say robotics specifically because I think software and AI is also trying to go after the same category and say we want to sell, project management tools and CRM tools and things like that. But maybe comment specifically on the two things which Dusty does, which is the orchestration and then obviously the layout. Where are we in the adoption curve? If 1 is nobody's using it and 10 is can't live without it.
So we are going to be the standard on every single job site in the future. And we're on our way to that. Yeah. Because there's it's stupid to think that anyone's going to go back to the old way of doing layout once they've experienced automated layout. Mm-hmm. And so the way we're getting there is we've started with the subcontractors who have adopted us as a labor replacement tool. We've expanded to the general contractors because what we have for them is not just a layout tool, it's actually a layout workflow that gets all of their trades on the same page. And the next step and where we're going from there is getting the owners to start mandating this on their jobs. So we have some of the big tech companies mandating us on data centers. We have some of the big hospital chains mandating us on hospital build-outs. And so that's how we become the de facto standard.
If we were to call up a tradesperson who is on a site using Dusty today, where would they say, oh, I'm so happy that we're using this? And where would they have potential concerns?
So our customers love us. And so I've got a million quotes. So one of the ones that stuck with me is the Anning Johnson foreman who told us, so Anning Johnson's a drywall contractor, and these guys were based in Southern California. And they said that one of the things I love about Dusty is that it lets me sleep at night. Okay. So imagine that statement, right? His job is he's the foreman for this drywall contractor, And his job is to make sure his crews build the right thing. If they don't, it's on him and it's his fault. And so Dusty is a tool not just to print the lines on the ground, but to also train his crew on what to do. And he can be confident that Dusty is printing the right things in the right place so that he doesn't have to worry that he made a mistake, because it's those mistakes that keep him up at night. If he made a mistake and his crew built a wall in the wrong place and his company has to pay to like rip it out and replace it, that's on him. Yeah. And he just personally cost his company, could be millions of dollars. And so this tool gives him that peace of mind that when he's doing his job, he's doing it right.
I think that's the biggest thing about construction over, let's say, categories like manufacturing or shipping or logistics, is the permanence of the error. I was thinking about this as you were talking, which is like, yeah, we've seen folks that have put, manufacturing robots out there. And if you have a defect, you have a defect. There's some allowable tolerance. And then like, okay, maybe you have to change the line over. But if you literally put piles in the wrong spot or, whatever, we've seen this happen on a home building project where, the wiring was supposed to go here and somebody changed it and the water main went there instead. And now you can't put electrical in that part of the wall, right? That's what I'm like remarking on here, is like just the permanence of it. How often do you see these stories where folks say, yep, I had somebody put the wrong thing in the wrong place?
All the time.
And what's the setback for a project like that?
So this one made the news. There was a 43-story tower in San Francisco from Hines. They're a big real estate developer. And there was a construction error on the top floor, and it caused one of the water mains to burst. And water went through the entire building. All like 1,000 apartments became uninhabitable. They had to like evacuate the building, put everyone up in temporary housing. These were all like owned and purchased condos, and so that was a mistake that the construction company now has to own.
Yeah,
because that defect is impacting people's lives and their own livelihood.
Yeah. Let's talk about form factor for a second. We've talked for a half hour. We haven't brought up the humanoid word. And this is now the talk of the town. Seems like every other week there is a new humanoid company that has raised, name your hundreds of millions of dollars. What do you think about the humanoid form factor in construction? Let's set layout aside for a second, right? Dusty is going to be the industry standard. Where do we see humanoids in Jobsite?
All right, so I had to look up the term steelman proposal, okay, because I hadn't heard that before. So I'll give you the steelman version first of why humanoids, right? Our world is designed for humans. The chairs that we're sitting in, the table, this height, everything around us, our cars, our appliances, our devices, they're all meant for humans and our form factor, right? This cup is the shape it is because my hand can fit around it, right? A 2x4 in construction is the shape it is because a man can put it over his shoulder and carry it onto the job site. And so that humanoid shape has driven everything in our world. And so humans are so versatile, we can do any job in the world. That's just the nature of how we've constructed our environment around our form factor. And so because we've architected our physical reality around the human form factor, a human robot has the potential to take on any job that a human could do, right? And so the thinking is, if you can just put the right brain inside that human form factor, you'll have a general purpose tool that can automate any job in the world.
Okay. So you've steelmanned it for me.
Yeah.
Now tell me why that's wrong.
So the reason it's wrong, I will tell you, you already have a robot in your kitchen right now. I guarantee you. Yeah. It's called a dishwasher.
Yeah.
Right? Yeah. If you want a better dishwasher, you upgrade your model to a better one that has more jets or, better water capacity or whatever, and you have a better tool for that job. And that's a purpose-built robot that does one task really, really well. Mm-hmm. And you don't have a human standing in your kitchen washing dishes. You put it in the dishwasher. Yeah. And so if you think about construction and you think about the job that Dusty's doing, we're replacing a process of people snapping chalk lines. That's when you take a piece of string, it's been dipped in chalk, you stretch it between 2 points and you snap it. And that leaves a line of chalk dust on the ground, and that's how they mark locations on a job site. That's how you draw straight lines. The Egyptians invented that to build the pyramids 5,000 years ago, okay? So if you think about doing that task with a humanoid, do you really want a robot on its hands and knees snapping this chalk line? No, you don't. That's not the best way to do this job. And so a purpose-built robot is always going to be better than humans. at doing these things.
I'll push back in one regard, and maybe this is just because we're thinking about what has been as a construct of what can be, right? You have a dishwasher because for a long time you needed to take a physical human that was at the sink washing the dishes, and now you now have a machine in there. And we may be heading to a point at some point, if there's, let's say, humanoids in the home. And I'm using the home as an example because it's easily accessible, but we can apply it to any job that's being done. Painting a wall, putting down flooring, whatever. At a certain point, are we trying too hard to design for the world that we have already built for humans versus maybe saying, okay, well, what if we reimagined the way that the kitchen looked or the way that drywall installation looked, electrical looked? Does that push us closer towards generalization or more towards purpose-built?
I think it's always going to be purpose-built.
Really? Okay.
Yes. So I can't wait until my closet turns into a washing machine, right? You hang up the dirty clothes and you pull out the clean clothes.
Yeah.
And that's just a different form factor, right? Or you can try to sell me a humanoid that'll load my washing machine, fold my clothes, and hang them up in the closet, right? I know people are trying to solve those problems. But which one of those is going to win, do you think?
No, I think if I'm able to build my house from scratch today, I would totally do that. But I live in a 100-year-old apartment building in New York City. I don't have that luxury. So I probably need something that's going to adapt to my environment versus, having to build it from scratch. What I'll say on this piece is, again, using the home as an accessible example, we have a lot of OEMs in the home, right? We have our refrigerator, we have our thing. My KitchenAid mixer technically can be considered a autonomous robot if I let it make pasta long enough. And I don't connect any of these OEMs. They are all independent tasks. And at no point have we ever thought about, okay, well, what if we connect this? Taking that now to the construction site, if we have 6, 7, 8, 10 purpose-built robots, one doing painting, one doing flooring, one doing layouts, who owns the connectivity? How do we get these things to actually work in concert with each other?
Well, I swear I didn't set you up for that. So that's what it means to be the orchestration layer for construction. And so that's what Dusty is doing. If you think about it, the marks that we make on the ground, right now, today, they're interpreted by humans. And humans are using those marks like Lego instructions to figure out what pieces to put where and how to assemble the building. But tomorrow, when robots are doing that work, they're going to work off of similar marks because the hard part is knowing where you are and what to do there. And so if you think about it, what Dusty is putting down is the positioning layer for all of those future robots to know where they are so that they can do their job correctly. One example, there are all these drilling robots now, robots with an arm that can automatically drill into the floor, into the ceiling. And some of those robots are actually working off of the marks, the X's that Dusty is printing on the ground to know where to put those holes. And that's what it means to be this orchestration layer for construction. We are conducting the orchestra. We're telling all of these instruments or these actors in this construction ecosystem what to do and where to do it.
On a technical level, does that mean having an open SDK or APIs? Or what is that?
On a technical level, that looks like QR codes.
Really?
Yes.
Okay, wait. Okay, now I need to understand. How? What? How?
Okay, so you've probably seen some videos of our robots. They're printers. They mark lines on the ground. They write text, and they can also print QR codes. And those QR codes are at a very specific location with a human and a machine-readable code. And that machine-readable code is something that only we have access to because we put it down in the first place. And so that code can embed a location. And so imagine a future in which every single robot that operates on this job site scans those QR codes, knows that it's in room 242, and it knows what it needs to do right there.
This is the bathroom. We know that this is the bathroom. Please make sure that you leave room for a pipe.
Yes, install the outlet here.
Without having to have a foreman on site to say, hey, this is...
Or without needing its own positioning system.
Yeah.
One of the challenges in construction is that all of the technologies that robotics has invented, like SLAM, doesn't work in construction. Okay. Because SLAM senses the walls in order to tell you where you are. We're coming in and operating when there are no walls. Mm-hmm. And so, and the environment's changing every single day. You don't have that consistency. So you can't build a model of your environment and you can't use the traditional robotics tools.
How much of that intelligence has to live on the robot itself? Guessing you're operating in some remote environments. We were just with our mutual friend, Puneet at Grit, who operates in the boonies of Texas and Michigan. Connectivity is a problem at that point. Getting inference at the edge is a problem at that point. How much intelligence has to live on the robot versus in the cloud?
So our philosophy is that we're building a power tool. And it's something you should be able to pick up and use. You shouldn't need internet. You shouldn't need any kind of access in order for it to do its job. And that was something that we learned after like observing lots of construction sites and seeing how they use their tools, right? We've operated in sites where they're GPS denied. You're in the basement and you can't see the sky. We've operated sites in the middle of nowhere where you're building a data center and constructing the cell towers that are going to bring you internet access. And so we have to be able to deliver systems that don't require modern infrastructure in order to work.
Yeah, I can imagine too if you're thinking about defense use cases now as well. You probably don't want to be connected in order to give away your position if you're setting up something in a forward operating way. On the technical side, what does that mean actually to make it a power tool? Like what has to live on the machine itself?
So because our philosophy is to build a power tool, one of the principles is that it has to be predictable. You turn on your impact driver and it always turns the same direction each time, right? There's no non-determinism in that. There's no AI in that. And that's a kind of controversial statement these days. Yeah. But if you want to build a power tool, you can't have it learning on you and doing something different tomorrow than it did yesterday. Because what we see in the construction industry is that because they are so risk averse, they need to be able to trust. And in order to trust, it has to be predictable. In order for it to be predictable, you have to basically do the same thing today that you did yesterday. Mm-hmm. And that predictability is what creates the trust, that creates the adoption.
And when you go in with that sales pitch and say, there's no AI on this machine, are the GCs more comfortable or are they kind of looking out and saying, well, I hear there's AI in everything today. Shouldn't we be using it too?
I think VCs are the only ones that care about AI on robots these days. Our customers don't care. They just want it to do the job.
The amount of money that has gone into robotics, and coming back to the, where we opened the conversation today, where does it all lead? Let's look forward a little bit. There's really kind of two tracks, the purpose-built track and the generalized track. Dollars-wise, I think, there's one group that is hogging all the dollars and all the attention. Think ahead 5 years for me. What does the robotics industry look like?
I think the challenge in bringing robotics to market is the market part of the robotics. And it's really understanding the market enough to know who is going to pay for this solution, enough to fund the development and the productization and the eventual go-to-market, right? And so that's a high bar. But I see some companies actually getting there. And so I'm excited about that. And that's why what we're investing in is the orchestration layer for all of those robots. So let's let 1,000 construction robots bloom, and we will happily sell you the platform layer that tells you where you are and what to do, right? So that's our vision of the future. Where I see funding going is what I would say is that anyone investing in humanoids is probably really stupid right now, because I don't see that going anywhere.
Really? Not even in it's not 5 years, maybe it's 10. You just don't think it's going anywhere?
I just don't think it's going anywhere.
Why is that?
The same reason you'd rather have a dishwasher than a humanoid standing in your kitchen.
I get the safety concern. I don't want my 3.5-year-old around a thing. But if it's operating at night while we're all asleep and it's, doing things. I let my dishwasher run at night when I go to sleep, right? So wouldn't my humanoid be able to vacuum? No, and again, we're using the home as an accessible example, but I even mean on a construction site, right? What does it mean to have a data center that builds itself over 24 hours because you're able to cycle through a bunch of different use cases? Instead of having to load in 40 different pieces of equipment, am I able to get value out of one, right? So sure, you can say cost to cost, maybe it's $5,000, $20,000 robots or $100,000 humanoid. Okay, you'll say dollars-wise, that's comparable. But we haven't talked about getting it there. These are now 5 pieces of equipment that could break down. Each one has to have its own service. There's one humanoid, and it's brought to me by one OEM. And if there's an issue with it, I've got one person I've got to call that can potentially fix it. So I hear you that like, and again, I would expect you to say that purpose built is the way it goes. But if I'm actually thinking about like where the humanoid could be useful, it's general purpose for a good reason.
What our customers tell us is that they have yet to see any good use case for humanoids on their job sites. And no one's figured it out yet.
Yeah.
So I'm not saying no one ever will, because I can't see the future, but no one has.
But the quantum of dollars going into it for the chasm of customers saying, I don't have any use for it, and the dollars going into it on the other
side. So
That's like that.
Construction is all manual labor, right? I think more than half of the cost of a construction project is manual, physical labor. And so that's enormous. And so labor is like a huge part of construction as a result. And it's hard for people in the industry to see any other way of doing things, right? And so they think, okay, well, if my entire construction project is done by labor, well, then I have to automate that labor. And so they look at humanoids and think, okay, maybe that can replace my one for one.
Yeah.
But that is not the right way to think about it. Because what's actually happening, if you're not paying attention to the humanoid hype, and you're actually looking at what's working, is that some of the more successful contractors are doing off-site construction. They're doing prefab.
Yes.
And so that turns construction more into a manufacturing process where you're building the pieces in a factory and then you're bringing them on site. And when you're on site, you have very little assembly work to do. That's the way it's going to happen. And where Dusty fits into that is once you actually are on site, automated layout is more critical than ever. Because if your pieces don't fit, you have to go back, do a round trip to the factory. You can't just modify it in field. You don't have the labor, you don't have the skill set anymore. But that's the direction it's going.
The prefab takeoff has been really underreported compared to this. But when you think about how many homes were short in this country, like 750,000 or 1 million, depending on some estimates, factory production is the only way that we can reliably get there, right? And so I'm with you, which you're right. If you have to then send all those frames back because you cut them the wrong way, that is a very, very expensive proposition.
And then that's the solution to the skilled labor shortage as well, because those factory jobs are better. Yeah. You're not in the heat, you're in an air-conditioned space, you can do a thing that you're good at, but you can do it in a comfortable environment. Right? And then we can also start to automate that just the same way all the other factories are getting automated as well.
As a technology business, when you look at even just the last 6 months, as a VC, it makes my head spin, but like every week there is a new model that comes out. There's a new NeoLab that comes out, new purpose, small LLMs because they're very, very focused on medical use cases or transportation or supply chain use cases. Does that excite you or scare you as a founder? Just the speed at which we're seeing frontier level models accelerate.
It's both terrifying and exhilarating at the same time.
Okay.
I think the exhilarating part is that everything gets easier. My job gets easier. Engineering gets so much easier. Mm-hmm. Pretty much any knowledge work gets easier with the frontier models. And so that means that what used to take, this many resources and this long now takes a lot less. Mm-hmm. And so that means that as a company builder, I can build faster with fewer resources. And that efficiency is really exciting. It's because I'm seeing so much more potential thanks to AI. It's terrifying because I don't think we understand where it's going. Not to my knowledge has anyone cracked AGI yet, right? But, at the pace that we're going, who knows what's going to happen.
I know they're two sort of separate ideas, but AGI and the embodiment of AGI being humanoids, I think is sort of a connected story. If you're right, and 5-6 years from now, that intelligence just lives in a screen, I don't know how much it matters for the GC.
It lives in a screen, but it still impacts a lot of the work that happens.
Okay.
I mean, if you look at what Dusty does, it's pretty simple, right? We're a little printer robot that draws lines on the ground.
Sure.
But how does that data get there? That data is the orchestration layer for the job site. And so everyone who's looking at our marks is going to do something. They're going to build something. And one of the coolest things is that because we're printing a lot of words and instructions on the job site, people are reading those words and taking action as a result. Mm-hmm. And so we're actually giving instructions to the people in the field, right? Now imagine that it's AI writing those instructions.
Right. And it's able to adapt in real time and who's on site today. And it's like, Jay, this is your job written on the ground as I get there.
You'll be scanning a QR code with your phone.
That makes more sense. Yeah. Tessa, I want to talk about the data piece, actually. So you brought that up a couple times. Today, we're seeing real job site data, real camera data, real layout data be super valuable to other robotics companies. As you become the orchestration layer, are you sharing that data with other folks that would be building on your platform? Or is that kind of...
Why would we do that? I view data as one of our moats, right? We're the most deployed construction robot in the world. We've been on more job sites, printed more projects than anyone else at this point. We've printed over 350 million square feet of layout. And all of that information is information about how people build. So you can imagine that's a really valuable asset for us to hang on to and possibly and leverage.
Well, I was going to say, that's also a really valuable asset that a lot of robot labs today would pay for. So when you talk about coming back to our first point of building a product versus building a company, one potential way to build a company today is to sell data to robot labs. Let's think about the future. You've talked publicly about your goal of taking Dusty public one day. What needs to happen for that dream to become a reality?
It's really about becoming that orchestration layer for construction. It's about fleshing out that positioning layer. Part of it is about seeing more robotics solutions come up and being that platform for them, right? But then, I haven't seen any reach the same scale that we have yet, and so it's a little bit early for that. It's really about, our vision inside the company is that we have a Dusty on every job site. Because layout happens everywhere. It happens on every single job site, no matter how big or how small. And we want to be the solution that helps that building get built. And so our customers tell us that we're inevitable. Part of it for me is just building the business that they're expecting us to be. And that's how we go big.
And then I guess what I'd love to close on with you is, outside of technology, what are the biggest headwinds for getting more robots onto these job sites? And what are the tailwinds that you see looking ahead? What keeps you excited about more robots on the job site in the next 5 years?
I think the headwinds, I'm going to bring this back to where we started. Technology is easy, behavior change is hard. And so the hardest thing to solve for in a legacy industry like construction is that behavior change aspect. People are used to doing things a certain way in construction. They did it the same way their dad did it, the same way their grandfather did it, all the way back, because that's the lowest risk way to do the thing. Your ancestors have figured out how to do it well. And so your best bet is to keep doing it that way. And that inertia is both a blessing and a curse in construction. It keeps us safe because we've learned how to do things in ways that keep workers safe and deliver the right result. But it also makes it challenging for startups like us to change that behavior. That's why one of the things that we talk about internally is that we have to be 10x better than the status quo. We have to deliver value that's perceived as so much better than the old way they were doing things, and that's what makes it impossible to go back once you've tried the new thing. That's what is going to make it irresponsible not to use Dusty when you have the opportunity to. That is the headwind that we're fighting. We obviously have ways that we're approaching that problem to eliminate that headwind and turn it into tailwinds. And so that's how we're managed to grow and continue to scale in the industry. In terms of what I'm hopeful about, look, construction is the biggest industry on the planet. It's one of the oldest, and it's the second least automated. It touches all of our lives. We're sitting in a product of the construction industry. You live in one, you work in one, you play in one, right? It touches all of our lives every single moment of our days. And so making an impact on construction is something that is going to change all of our lives for the better.
Tessa, that is a wonderful place to leave the conversation today. I have really enjoyed following Dusty's journey, and I hear you. Some of these examples are mind-blowing, right? Just 1 foot over the property line, or a single water main having to replace 240 residents. The permanence of it all, I think, is the thing that I'm really left with here, which is you work in software, you write a bad piece of code, you might lose a little bit of money. You mess up something in construction and there are lives at stake, not just in the pre-construction phase, but after the building may be completed. And so the permanence of it all is what lasts with me. And I'm excited for Dusty, which is already one of the most deployed robotics product out there, to continue leading the way. So thank you so much for joining me on Fun today.
Thank you.